Let's get started. So, hello everyone. Today we are going to talk about our project, machine learning-based quantitative trading strategy. So, in this project, we hope to bridge the gap between the theory and reality. Our project is to separate into two major sections, the models and the software implementation. The superiority of machine learning among traditional models in trading is further discussed. Honed with effort, we will introduce a simple trading platform for automated trading. And several strategies are refined and integrated with our corresponding machine learning models. A series of comparison will be conducted between machine learning and traditional models. Only models with enlightened results will be embedded in our trading platforms. So first, let's get started with our non-machine learning models. So we finalized two non-machine learning strategy which has the best performance. So the first one is a statistical arbitrage pair trading, and the second one is a defensive portfolio management. Here is our development pipeline for the non-machine learning pair trading strategy. So first of all, we collect data from Yahoo Finance using Python API, and then we prepare the data by removing the null data from the close price data. And then we select the trading pair using co-integration method. So basically, we select all the co-integrated pairs from S&P 500 stocks. So later, we will write the pair trading strategy and then backtest it with the selected pairs using backtrader. And then finally, we will improve our trading strategy by tuning the parameters for better performance. So this is our logic for the non-machine learning pair trading. So first of all, we select the pair by co-integration method, and then we compute the price ratio by dividing the two prices of the two stock, and then we compute the short period and long period moving average of the price ratio. Later on, we compute the EZ score based on the short period and long period moving average, and also the standard deviation of the long period moving average price ratio. So if the EZ score is larger than the upper threshold, well, then we buy stock 2 and then we sell stock 1. If the EZ score is smaller than the negative upper threshold, we reverse the action. And finally, if the absolute value of the EZ score is smaller than absolute value of the medium threshold, then we close all the position. So these are the parameters that we use to tune for to optimize our strategy. So we have the upper threshold, which determine the entry signals, and then we have the medium threshold, which determine when we close the position. So we also have a short period average looking back and a long period average looking back. So basically, it's the looking back time for the two moving average. So these two variables affects the computation of the EZ score for pair trading. So we backtested the non-machine learning pair trading strategies. So these are with an initial deposit of $100K. So these are some example results, and you can see here is the Sharpe ratio, and these are the final portfolio value using the data from 2013 to 2023. And we discovered that tuning the median threshold give us the best improvement in the trading strategy. So these are the median threshold that is optimized for each of the trading pairs. So now is some demo for the pair trading strategies. So first of all, we have ARE ADI pairs. So the Sharpe ratio of this strategy is 1.125, which is quite good, because if the Sharpe ratio is above 1, then it's indicating a good performance. So you can see this is the entry sell signal. This is buy for the one stock and the second stock. So these are the cumulative return of the portfolio using the 100K initial deposit. Well, this is the second backtest results we have. So this is the ADBE and RMD stock pairs. So now the Sharpe ratio is smaller, because you have a larger drawdown in the period, so it indicates there is a higher risk in the backtest. So also we have like a third demonstration of ANSS and RMD. So this is Sharpe ratio of 0.565. So now we are going to talk about the second non-machine learning strategy. This is the defensive portfolio management, which is the asset rotation strategy. So this strategy is based on 3 macroeconomic statistics. But the first one is the U curve, which indicated economic growth, with the high U curve indicating strong economic growth and inverted U curve indicating possible upcoming recession. And also we have a break-even rates representing a measure of expected inflation rates. And then we have a 20-year maturity bond yield, which indicate like the entry signal for invest in bond. So these data can all be downloaded from the Federal Bank website. So these are the trading signals we use. For U curve and bond yield, is still the same, but we compute a new signal called stagflation signals. So it's basically using the 10-year break-even inflation rate, which means the expected inflation minus the U curve signals. So if the stagflation signal is high, it's indicating a high inflation and a slow economic growth, which signal the gold investment. So as you can see, this is a visualization of the trading signals. We have a red curve indicating the U curve, the green curve indicating the stagflation signal, and the blue curve indicating the 20-year bond yield. So these are the trading assets we use for this strategy. We have S&P 500 ETF. So because stock is historically performed well in under strong economic growth. So and we use gold share and also bond as a defensive asset. So during stagflation, because the economic environment is uncertain, so we use gold as a defense. And if the bond yield is high, we will use bond as a defensive asset during the economic downturn. So what's our logic? So first of all, we retrieve the free economic data from Federal Reserve Bank website. We compute the stagflation signals, and then we compare each trading signals. So when the stagflation signal is the highest, we rotate the capital to the gold share ETF. And if the U curve signal is the highest, we rotate the capital to invest in the S&P 500 ETF. Well, lastly, if the 20-year bond yield is the highest, we rotate the capital to the 20-year Treasury bond ETF. So this showcase the price data for the 3 assets we have. So we have SPY, gold, and the 20-year bond. So the blue region indicates the time where we rotate capital to the corresponding assets. Like for example, here we rotate to the S&P. Here is a gold. Here is for the 20-year bond yield, 20-year bond. So so here's the backtest results for our strategy. So as you can see, the orange curve indicating buy and hold strategy of S&P 500 ETF. So for the blue curve is the performance of our strategy. So comparatively, we can see a much higher return. So in summary, non-machine learning model is perform quite well and is also provide a good insight for later comparison with machine learning models. So now we move on to Victor to allow us to explain more about the machine learning model.
We cannot hear you. Can you speak louder?
Share, give me the right to share the screen.
Yes, okay.
Can you hear me? Okay.
Yeah.
Oh,
Ricky, mute yourself.
okay. So next we will be talking about our 4 distinctive machine learning based model. And the first one will be the reinforcement learning model. The second one will be the RNN one. And the third one will be a binary classification one. And the last one will be the clustering-based one. So for the multi-model based binary classification, the underlying logic of this model is to utilize all of the scalar model for binary classification. We have used classifiers and regressors for classification problem. Our problem intends to fit the data with the continuous regression to yield discrete classification. In fact, the backbone of logistic regression is purely linear regression. Therefore, the logistic function is a linear function wrapped in a sigmoid function. Albeit with a narrower decision boundary, regressor can actually achieve the same accuracy as classifier. Our model hereby approach classification through regression. So for our model context, we have utilized about 68 of the models with 10 forex data and 10 stock data, also 2 scalar, and they are the mass mean scalar and the standard deviation scalar. So theoretically, we should have yield about 2,720 results, but we only receive about 2,689 result. This is because of some of the missing data frame in the Yahoo Finance data set. Oh, next for the matrix we use for the classification, we have actually utilized about 27 of them, but we only use the accuracy score to run all of our model. This is due to our time limit for the project. And the results are not further processed due to our limited time. And for our model, so the model are supervised learning model. They use all of the scalar model with the default parameter setting. Prediction results of regression are normalized to binary output 0 or 1 to compare with classifier. Our data set separated into 2 main categories: data set that inherit only yesterday price impact and data set that inherits the historical price impact. My model actually analyzed the closing price of the historical market. If the previous closing price is lower than the current closing price, it is classified as a buying opportunity and vice versa. So you can actually refer to the data frame. The upper one is the data that we have received from the Yahoo Finance data set. And the lower part is the data after our pre-processing of the data. So it finally make a decision of 1. So for your reference, 0 means the sell of signal, and the 1 means the buying signal. Oh, you can refer to this diagram. So the left one column indicate the day of market day. So, and the second column indicate the decision made by our model. And the third one will indicate the actual trading behavior based on those decisions being made. So you can see that our model have actually triggered a buy signal at day 1. Therefore, it will buy an order because no previous order is being buy. And then for the second day, there will be another buy signal because we have already opened our position. Therefore, we will keep our position, and then up until the 4th day. So there is finally an close order signal. Therefore, we will close off our model. And for the binary classification model, all of our logics is based on this. And up until the final day, we will finally close all of our position. For the code explanation part, I will open I will refer to this Colab notebook for explanation. So you can see that from this line. So you can actually, by passing through in our asset report function to see the detailed report. So the detailed report will contain all of those classification matrix other than accuracy score. So, and also the current ranking is just based on the accuracy to minimize our complexity. And And I recommend you only refer to the first report, because the second report is the data that inherit the historical price impact. Although it's a good idea, but we have actually found that it's very time consuming to generate an entire new data set. Thereafter, I refer you only reference to our first data. You can actually see from this result, about 2,000 result is being generated, and result based on accuracy is being found. And you can actually see that the SVC is our best model. However, you cannot only refer to this result, because those results are only generated by using classification matrix, but we are dealing with a trading problem. Therefore, Sharp ratio and the correlation are not being deployed in this result. You may need to refer to the result in the slide that is in this slide for a detailed overview. So you can see that those are the top 10 classification model we have found for after our experiment. So the annual SVR and the MLP classifier model are the top 2 models. And all of the models are already calculated based on the Sharp ratio and the correlation. After that, let me pass my time to Marco for his explanation.
Okay, thank you, Victor. So I will now share the screen. Okay, so there are actually three other machine learning models we use in this project. So the first one is reinforcement learning. So what is reinforcement learning? So here is a demonstration. So basically, you can see a dinosaur is playing the T-Rex game, and when you see the obstacle, it will jump automatically, and you can see some policy update here. So we didn't give any decision rule to it, so he will learn automatically from the environment and also from the observation, and it will make the updates based on the reward. So this is the architecture.
I think you're in the wrong. I think you're in the wrong mode. I think you want to put it into slide mode, right? You're only showing. You didn't put it into slide mode. It's not in presentation.
slideshow.
Oh, okay. Sorry. Okay, so in this project, we will want to try the reinforcement learning with the momentum trading. So in our project, the environment of variables is actually the stock price, balance, and also the shares. And then the trading agents will test different trading agents, and the trading agents will make the actions correspondingly to the environments. So after the action is made, and we will have the reward. Yeah, and the reinforcement trading agents will decide whether what to update, and then do the optimization based on the reward. Okay, so let's get into the demo. So basically, I will do the demonstration on the DQN agent. So DQN is basically the full name of Deep Q Learning. Okay, so we will use the Python library offered by OpenAI, which is called Gym. So Gym is actually a pre-built, we provide a pre-built environment for reinforcement learning agents, and also is a standard API for communications with the learning algorithm and the environment. Okay, so in this, here I import the state size, action size, and also like the learning rates, discount rates, expiration dates, and then I will build a model because I am using deep Q learning, so I need to have a deep neural network here, and then I will also define the remember functions, add function, and also replay function. So these are like the control of the reinforcement learning. So by this graph, like the path here. And then it will automatically generate the signal. So this is like the buy signal and also the sell signal. So here are the comparison based on the Sharp ratio. I try different reinforcement learning algorithm. So the threshold means that, like Vicky says, the higher the Sharpe ratio, the higher the performance it is. So we can see deep Q learning reinforcement learning algorithm has the highest Sharpe ratio, but you can see the threshold is just 0.4, so which is not a good strategies. So we also try different machine learning models. The third model we use is RNN-based portfolio optimization. So Vicky had already told you something about the portfolio optimization. Traditionally, we will use the historical mean and also historical standard deviation. But now our idea is use the predicted price. Yes, but how do we know the predicted price? Then we use RNN to predict the predicted price. Okay, and then we do different experiments on the RNN model. So we have to determine which RNN model to use. Okay, and in this project, we tested 5 different RNN models. And amongst our 5 RNN models, we find that the bidirectional LSTM and also LSTM have generally better performance, in predicting the stock price. So in this project, we decide to use LSTM model and stick to LSTM model, and we use the LSTM model to do the prediction, and we use the predicted historical mean and also standard deviation, and then we do the portfolio optimization. Okay, so here is the backtesting results. So we can see the return and also for velocity here, and volatility here. And so here is a demonstration of how the distribution of the return or risk of the portfolio. And here is the cumulative return. So you can see the cumulative return is actually 120%, in 2 years. So which is not a bad performance. So I will compare different models in the later stage. So let's get into the last model first. The last strategy we use is clustering-based pair trading. So in the traditional pair trading, we usually do the pair trading inside a particular industry. For example, like because we have the assumption that if stock belong to same industry, they should have similar price movement, like HSBC, Bank of America, Bank of China, and then we can take arbitrage opportunity. But the definition of stock being so confused nowadays. For example, like Tesla, how can you classify it? Someone will classify it as the automobile industry. Some will classify it into renewable energy, or maybe in the technology sector. So and also some other researchers will also do the pair trading using different traditional approach, like the distance approach, co-integration approach, time series approach, and also stochastic control approach. But in this project, we want to stick to the machine learning approach and see how we will perform, and we choose clustering-based pair trading. But of course, we have to decide which clustering method we use. So we have to do experiment again. In this project, we tried 3 different types of clustering method. The first one is the hierarchical clustering. The second one is the affinity propagations, and the third one is the k-means clustering. And we compare using the clustering score. So the clustering score is actually the measure of the quality of the clustering. And usually higher the coefficient is, the higher the quality it is. So from the experiment, we see that the k-means clustering actually having the highest score. So in this project, we will stick to using the k-means clustering, and do the pair trading. Okay, but now we get the k-means pair trading, k-mean model, but how to determine the k-value? K-value is just the number of cluster. So we have to do experiment again to find the number of cluster. So we use elbow method. So elbow method, and then we can see from the experiment the optimum value of k value should be 5. So we will use classify the stock under S&P 500 into 5 different clusters, and then do the pair trading. So we will find a pairs in of 2, and we can see the number of pair is actually 30,000 pairs, so which is too many, and we want to find the most promising pairs. So that's why we have to apply the different filters. And for the filters we have the co-integration task, correlation task, like the mean reversion task, and also the mean cross task. And then we also need to do different experiments to control the parameter, like how much what is the correlations correlation we need to use, or like the HKUST exponent. Different statistical tests will be used to find the most promising trading pairs. So here, there is the backtesting results. So you can see generally the performance of the clustering-based method. So we can see the return is actually quite good, and also we can see a stable uptrend here. So which means that the standard deviation of this graph is very low. So which means the risk is low. So I think it's a very good strategies. Okay, but how do we determine a good strategies when we do the comparison? So just like what I mentioned just now, we use the Sharpe ratio. So Sharpe ratio is just like the return of portfolio minus the risk-free rate, and also divide the standard deviation. So standard deviation being the risk, and the return is actually on. So we want to maximize the return and also minimize the risk. So which means that higher the Sharpe ratio is, generally better the performance is. So we compare our pair trading in this project. So the Ficky's statistical arbitrage trading. So the Sharpe ratio is actually 0.9, and for the K-means clustering method is 1.6. So so compared to other traditional approach, so we can see our strategy is actually perform better than theirs. And also we will compare the portfolio optimizations. So we use the defensive allocations strategies and also the LSTM one. So we can see both of our strategies perform better than the traditional one. And you can see the LSTM one performs slightly better. And also the time period asset, of course, is the same. We have to have a fair comparison. And for the final one is the momentum trading comparison. So you can see for the Victor's multi-classifiers, so the Sharpe ratio is actually 1.1. And for the reinforcement DQM method, so because we know the DQM is the best algorithm from our experiments, and the Sharpe ratio is just 0.4, so which is not very good. Okay, so let's rank the machine learning model, because we focus on the machine learning models in this project. And the first one is clustering-based pair trading. The second one is the portfolio optimizations. And the third one is binary classification using multiple classifiers. And finally is the reinforcement learning method. So here are some improvement or the reasons for the performance. So for the clustering-based pair trading, so we actually can, our observation is that more the filter we use, of course, is relevant filters, and usually you can find more promising pairs. And for the portfolio optimization, we can try different prediction models. Like in our projects, the RNN models we use is maybe still too simple. So I know in other researchers, they will use a more advanced prediction models. And or maybe you can try different portfolio optimizations. And for the multi-classifiers, and we see not all of the indicators are performing good, and some and if we use that kind of information, maybe there will be too much noise, which may lead to some incorrect decisions. And also we can also include the sentiment score, so which is a common approach in the momentum-based trading. So the final one is the reinforcement learning. So in the reinforcement learning, we just use the price variable. So maybe the information here is too simple, and also and we will need to give them more information, maybe like sentiment score again, or maybe any variables inside it, we can combine it together to form a new strategies, or we can provide a more reinforcement learning algorithm. Okay, so this is like the research we have done for the stock trading strategies. So in the following, Thomas will explain about our trading system.
Thank you very much, Marco. I'm Thomas, and I'll be presenting our software development user interface to you. So First of all, in this project, we try to prove that machine learning is useful to individual traders, and the above models that we present proves pretty well that it works for small funds with great Sharpe ratio. But at the same time, we also want to allow individual traders to trade with our machine learning models without requiring extensive programming knowledge. To achieve this, we developed a user-friendly interface for individual traders so that they have a simple and abstract way to control our models. The software we developed provides the ability to control over strategies that is already created by us and implemented into the system. Traders can then check the strategy performance by watching the return of the strategy with on-pivot trading, and then permit the model to trade in real market for them if they believe that the model has a good performance. They can also turn on and turn off the model in order to better adapt to the market. The system will do the trade on their behalf based on the model they turn on. And to conclude, our system provides four main functionalities. So first of all, you can register and log in as different users. Second, you can add or delete models from user account with risk control. Third, you can start or stop the model from time to time. Fourth, you can do trade in two different environments, on paper trading environment or real life trading environment. So now I'm gonna give you a brief look to showcase our software, our user interface. So first of all, you can see that, let's first log out the system. So you can see that this is a simple login and registration page right here. You can register and log in with specific accounts. It will then authorize using secure cookie session and anti-CSRF token header for protection. Now I have a testing account, so I will use this as a demo right now. After login, when you first get in, you will see that this main dashboard. This dashboard shows multiple data with your account portfolio for better overview and overall analysis. So here you can see some of the data like the total investment amount, total profit, the overall investment return rate, and the average monthly return rate. Then some of the portfolio distribution, like a stock distribution, investment distribution, and return distribution, so you can have a better overall understanding of your portfolio allocation. And you can compare the model performance and check the performance over time in the bottom. After, you can take a look at the next page, add models. So in this page, you can add some of the model that is not currently in your portfolio, and we have added and implement in our system. So we can, let's say, add the reinforcement learning model. You can set an assigned amount, let's say 3,000 USD, and then you will set a $100 loss stop. So after you add the model to the portfolio, it should pull up a success message, and we can check the model in the view model page. This page will provide you an overview of all of your models, allowing you to do simple control over them. You can delete a model. We can delete the model we just added to showcase. We can also start and terminate a model. And we can go into the model to view some of the more details of the models. So after you went in, we can do some further analysis of the model. We can see the model profit. We can see the standard deviation of the return. In order to analyze more on this risk, you can also start or stop a model inside here. And one additional feature would be to turn on the real life trading here, but you need to set your IBKR account API before you can turn on or use this feature. So if you want to set your IBKR API, you should go to the setting part. In the setting part, we only support IBKR API right now, but we may add more support to other platforms in the future. So we have also some simple, translation and theme changes here. And basically, that's all of our software functionalities. Now, to conclude, very simply, we built all of this model to prove that machine learning works really well for individual traders. And I think we successfully proved that it's true. And most of our model performed well compared to most traditional strategy. And we also made a user interface for individual traders to better make use of our models. So we performed a simple user acceptance test with several professional traders that we worked with before. And I believe that more than half of them are quite satisfied with our system. So I believe that we achieved what we aimed for in the beginning of the project. This is the end of our presentation. Thank you. Please let us know if there is any questions that you want to ask us.
Yeah, maybe I can start to ask several questions. First of all, I'm not very clear about the data actually you are using into your machine learning model, because from my understanding, basically for a machine learning model, it's very important to talk about how you actually organize your data. For example, how you learn the features, right? Do you utilize a handcrafted way for you to prepare your data to have your features, or you directly learn the features from your data, and you have end-to-end way to learn the features and learn the machine learning model for the prediction? So you didn't talk about these details. Maybe you can elaborate a little bit more on this part to make me understand better the whole pipeline.
Okay. So first of all, I would like to say that we don't have a, we currently have a system that pulls up raw data to the database, and we'll have different processing pipeline for different models. And I believe the pipeline are created by different person based on which models they actually learn or train. So I'll allow them to explain more on their own models data pipeline by their own.
Okay, so I think you are referring to the machine learning models. So the data we use is actually all of us come from the Yahoo Finance data, which is a Python API to get the stock data from the Yahoo Finance. And also we use the bar chart data, and we mainly use the daily interval. Yeah, so which means we have the close price, open price, or volume. But we most of us, if we do a models learns based on the price, we use the adjusted closed price. Yeah, and then because yeah, in the models, first we will do differently, because it's like a research, and only in the comparison stage we will use same data. So in the comparison state, because like we have pair trading, also we can have three classification. The first one is the pair trading, the second one is portfolio optimization, and the third one is the reinforcement learning, and also the multiple classifier. So the first one is, yeah, the last one is momentum trading. So you can see the data we use is quite different. So for example, pair trading, we use the stock under the S&P 500, yeah, from 2021 to 2023. Yeah, with the
I think you can probably just elaborate what the features. How do you obtain the features from your data, which are fed into your machine learning models? Yeah, I'm very interested in this part. The features, because you're not able to directly input the raw data into a machine learning model, right?
Yeah.
I mean, how did you obtain the features from your raw data?
You mean how do we do the training from the raw data?
So I believe that we do a simple trial and error. So basically, we will clean we have the raw data into our pipeline, and then they will do the. Obviously, we need to clean that data up and process the data before we put them into the system. First of all, we extract some of the data, like the items that most traders would actually use. So let's say we'll have some sort of the price point, like the highest ask or the highest bid, higher bid, higher ask of the day, and then we'll take the liquidity into it, and then we'll pass several more data, and we'll trial and error with different kinds of data and see which one works the best. I believe that most of us do a simple trial and error method with it and see which one performed the best. And basically we'll have a different combination of around I believe 20 to 30 data. And then they will do the different combinations and see like which one actually works the best, right? So I believe that is what most of us use. I believe some of them have their own choice of data processing, but I'm not quite sure about them. They can explain more on their model for you. Yeah, I believe that Professor Dan are talking about some more about the data processing and how you get the features, process the data to get the features into your model. Yeah, so Marco and Victor can talk a little bit more about that.
So for the binary classification model, first of all, we clean all of the NA data, null data, and then we will scale all of those columns, in a scale. So I've mentioned we have two scalar, the standard deviation and the mass mean scalar. So obviously the standard deviation has outperformed the mass mean scalar. And then after we have scaled all of those data, so maybe I can also share the screen. So this is the new data set. So how is it being generated? So first of all, this is for instance yesterday data set, and then this is the closing price of the previous day, and then this is the closing price of the today, for instance. So if the today closing price is higher than yesterday closing price, there will be a sell opportunity, and vice versa. And then after we have made all of those decisions, because all of those decisions are generated just based on the current day, so we have to actually shift all of our decisions down one row, and then therefore it can offset the effect of oversee forecasting the future. And then after we have made all of those decisions, for instance, let me make an example. So this is the first buying opportunity, and it will keep it will buying, and then it will close the position when it has encountered the first selling opportunity, and you will only open position if there is an other buying opportunity being found, and then it will keep the position. Yes, for the binary classification, the main logic is like this.
Okay, I think I got your idea. So you basically concatenate directly all the property values as a feature vector into your machine learning model, right?
So that's we take the data, and then we also create some variables that is most likely used by different traders. So like we talk about like Sharpe ratios and different kind of numbers that we input from we get from the API source, and then we compute some variables and save it into the database, and then we'll take up all of the variables that we created and the raw data, and then we create different combinations of this data and train a model with them, and then we see which one perform better, and then we use that as a way to filter out which features is actually most related to the models. Of course, this is not the perfect one, but due to the time limit, it is the most efficient one that we can find.
Great.
We then do some sort of
yeah.
feature extraction and something like that. Of course, we can dig in more and then work on the polisher features with correlations and but that is what we talk about the reinforcement learning, right? We want to make some more different features and then make it to work better, but because we have a lot of things to do, we have some sort of time limit. So deal, right?
Yeah. Great. Yeah, maybe I add another minor question because at the very beginning of your presentation, you discussed several thresholding strategies. I don't know how actually you determine optimal values for those hyperparameters.
You mean the non-machine learning models?
You mean the non-machine?
At the very beginning of the presentation, I think
Yes.
probably in the section of the binary classification, the multiple binary classification section, I talk about several thresholding strategies. There is a pipeline. I think we have different, steps, and you utilize different thresholding values.
So there is the multi-model based binary classification model. So it uses different models to do the classification part. Is that which one, that part that you're interested in?
I forgot which slide page, basically.
Let me, yeah. 你可唔可以 show 一 show 第24、22、23頁睇係咪佢問緊呢個？Are you asking this one?
No, not this one.
Not this one.
Yeah.
This one. Okay.
No, not this one. Earlier, I think.
Earlier. Oh, even earlier.
Yeah. Here. Page 8. Yeah. Here. Yeah. Yeah, as you can see from this slide, you basically talk about different thresholding values, right? How did you actually determine these values for you to select the model?
So maybe
you cross a validation or something else for you to choose optimal values for your model.
You mean for the C-score or the threshold?
For example, the upper threshold and the median threshold.
Yeah, the upper threshold and the medium threshold, like the different thresholds.
I think you talk about 4 types of thresholding values, I guess.
Yes, we actually did different experiments. So we have a for loop and then maybe correlate for the threshold C-score. We will test like 0.5, 0.6, 0.7. And also it's similar for the other parameter. Every parameter we do the same thing. We use a for loop and then we just test. Yeah, like our idea, our assumption is that from the training time period, if the pair trading, so it fits into a particular threshold best. So I think we will also fit in the future. So
yeah, so basically we need to understand that different pairs have different kind of thresholds. So some pairs would deviate from each other like more often. Some of the pairs may deviate less often. So we have to determine the threshold based on the pair itself.
Yes, so
which two stock that we are actually taking into account. 有聲啊，不過好細聲，你大聲少少。Yeah, so basically we determine.
Can I answer? Okay, anyone? Yeah, hear me? Okay, so basically what I did is, because I handle the non-machine learning model, right? So in the beginning, basically I do, because I cannot like directly like plug into all the pair trade, all the stock pairs, because so I start with the some specific stock pairs. So what I research is that basically you compute the ESA score, right? But then you kind of like I remember I do some data visualization of the ESA score, and then we kind of like determine the threshold based on the fluctuation of the ESA score, because usually the ESA score has certain like mean reversion property, right? So like a good ESA score is like it mean referred on the mean equals 0. So basically, and then you can kind of like determine the entry signal and the exit signal based on the data visualization. Like, so for example, like you have like a graph, and then you plot the upper threshold, second threshold. If it's too high, let's say, well, you can see like actually there's not many entry opportunity, so you cannot do anything. But so basically, we tune this upper threshold and lower threshold. We first of all we see based on the visualization of E-score, and then we backtest it in the backtesting engine and see its performance, and then we compare with the different values of the thresholds, and we discover that like actually the upper threshold, the best one is not that crazy. It's just like roughly one. It's roughly one. Like, because what we mean good is that it kind of like generalized to different pairs. Like the threshold one is not only like good in only one pair, but it also performed quite well in other pairs, but based on the backtest results. But for the medium threshold, you basically determine when you exit the position, right? Because it determines when you close the position. If it's too high, then you wait too long to close the position. If it if it is too high, well then you always close the position. You don't make too much profit in each of the trade, right? But if it's too close to the zero, well then you wait too long to take the close position. Well then there is some fluctuation that might affect the profit. So we kind of tune the median threshold. We discovered that tuning the median threshold kind of best improve the performance. Yes, so we kind of we basically first, we observe some pattern from the visualization of the e-score. We plot the upper threshold, median threshold, and then we backtest the result to verify the idea for each training pairs. Yes.
Okay, thank you. Yeah, I got it. Thank you. Yeah.
Okay, so I think we're running really late. So
well, we don't have the next group, right? So we should be fine.
I don't know,
unless we haven't have the lunch.
well,
I can send you the lunch if you want.
Well, Professor Xu, do you have another one to go to now?
Yeah, I have another one, but
yes,
it's starting from 2 p.m.
Okay, so very quickly, I'll just ask one question. If you had to add, if what's the most unsatisfying thing for you in doing this report? If you had to this project, if you had to do one, if you had time to do one more thing, what would it be?
One more thing. Can we answer, individually?
Okay.
Why you sound so sad about that?
Because it's a group project. Okay.
Because I believe that we integrate it eventually, but most of us work on different parts. So
okay. So yeah, so each of you. So if you could do just one more thing, what would it be?
Yeah. So I actually have a model that is a machine learning model, which didn't actually include in here because I actually kind of adopted it in the middle of the project because I have to do the front end because I don't have the time, and also I don't think it performs very well. So it's it's a high frequency, not really high frequency, but day trading, and then you will do a lot of trade inter-day interval with a rolling window machine learning trading.
So you need a very different type of data for that.
Yeah, and then I found that it actually works not as great as I expected because first of all, the variance are quite high. The Sharpe ratio are not, not quite good at comparing to other strategies. And I also have a pretty high commission fee because if you take in account into the multiple trading, trading amounts, the high trading amounts, it actually performed pretty bad. So if I have to go over, all over again, I would try to make I would still want to try to do a, interval trading strategy, but maybe with a little longer interval. So let's say instead of 20 to 30 minutes, I would try maybe a few hours interval or a day interval so that the model actually trade like 2 to 3 times a day instead of multiple times a day, so that I could kind of make it work. Maybe yeah, maybe others can also talk about what you think you can do better next time. Also next time I think we can do communicate and interact more. It's a good project. Maybe.
From my part, I think it's the reinforcement learning. So because actually I've seen that a lot for the reinforcement learning, but I found that the programming, so we did not learn in the lecture. So it's very time consuming for me to learn from scratch. And also, actually, my core idea is to use the reinforcement learning with the portfolio optimization and also pair trading, just like what Professor has said. So how to determine the parameter. So a lot of research stated that we can use reinforcement learning to do a dynamic parameter tuning. And also, maybe for secondly, I think it's we did the work quite late. So for the integration part, so everything is we have to rush everything, and then so
Okay,
I think the
that's fair.
cooperation.
Okay. Next.
I think for my part, I want to integrate better for the front end and back end, because I have developed some of the front end and back end that is based on all of the database. For instance, I have actually created a very generic API for the PostgreSQL, MongoDB, Firebase, Firestore. So I have actually created all of those operation to all of those databases. However, I only do until the authentication part. So although it can adopt to any system, but it only limited to the authentication part. And I have already developed it for over a year, rewriting the code over and over again. So I think I may try to put more time on the front end and back end integration in the future if I have time. So
Got it.
Yeah,
Next.
so actually I think about it. So I think if I need to do it again, I will improve this strategy, because for pair trading, I don't think the only thing a non-machine learning pair trading can do is, let's say, diversification. So you have more pairs, so you have more diversification to reduce the risk. But I think for defensive portfolio, you can see like here I choose the three most famous or most commonly used assets for the defense of trading. So let's say you have gold and ETF for defense, right? But I think like what I'm thinking is probably I can diversify these assets, like not only use gold and bond to do defense, and also diversify to other assets as well. So the risk factor might be further minimized, so that as Marco has said, because Sharpe ratio is determined by return and risk, right? So if the risk factor reduced, well, then we probably can like have a future boost in the Sharpe ratio. So that means like, yeah, so I think if I want to do it again, I will probably, yes, do more diversification for the defense strategy. Yes, because I handle the non-machine learning parts. Yes.
All right, so I think since we're really over, we should stop now. Thank you very much. Thank you to everybody, and I think we're over now. So, and to the group, I will just be sent. I'm good. I still have to mark your report. I'll do that, and good luck to you. I mean,
Thank you
it's,
very much.
Thank you.
Are
Thank
you
you, everybody.
okay?
Thank you.
Thank you,
Your
everyone.
sound doesn't sound right. Are you sick?
My
Or-
voice, my throat is sore. Everything else is okay. I'm not sick, but I have a very sore throat for other reasons. That's why.
I am kind of worried about the COVID-19 stuff
No,
that
no,
is going
not-
on again right now.
It's not COVID. It's
Okay.
only
Okay.
only.
Okay. Take
throat
care.
issue.
Take care.
Okay.
Take care. Take care. Do you
Thanks,
need some
Ashley.
sort of, I don't know, Chinese medicine?
No, I don't. All right. Be well. Bye bye.
Okay.
All right.
No
Bye-bye.
problem. Thank you very much. See you next time.
Bye.
Bye bye.
Bye.